Hello students, welcome back to Decode NCERT series. So today we are going to decode the chapter Alcohols, Phenols and Ethers from chemistry. Okay, so students, this is a very high weightage topic. So there are so many questions that can be formed from the text, from the chapter. I'll be giving you all those questions. You need to sit with a pen or a highlighter and a blue and a black pen, and you need to mark all those questions and you need to highlight all the important points that I tell you so that you can get full marks in this particular chapter. Okay, so now let's get started here. So again, I am telling you, this is not going to be any explanation video where I'll be teaching you the concepts. For teaching concepts, we have so many KCET videos are there to understand the concept. To practice questions, we have Brahmastra series, right? But yes, apart from this also, there are some things which can be asked from the deep inside of the chapter. Okay, so those all things I'll be highlighting you, but yes, you have to mark them and study them by your own. Okay, so first of all, here are some uses of OH group. Okay, the uses, I think it will be visible now. Okay, so you can see here some of the where the OH group exactly is used. Like here you can ask, ma'am, what type of questions can be asked here. See, there are very minimal chances, but since in chemistry the chapters are less, so it is a high probability that the questions can be asked from every corner of the book. Okay, so we need to be really prepared for this. So that is why here the question can be, there will be 4 options in which of this OH is not present, or 3 options will be there where it will be present or not present. So like MCQ question you can expect, so just highlight this point. Okay, but yes, this is very I can say less chance, but yes, we should not take any chance. Okay, next, what is an alcohol group? This is just a definition here. Like in alcohol, the OH group is attached to carbon, whereas in aryl alcohol it is attached to an sp2 carbon. Okay, so this is the definition of alcohol and phenols. Next, we have the definition of ethers. Okay, alcohol, phenols and ethers description. Next, we'll go towards the most important part, that is classification of alcohols. Okay, you can see here classification of alcohols. So there you should be knowing all the type of classification, what is monohydric, dihydric, trihydric. Okay, then you have here, what do you mean by primary, secondary and tertiary alcohols. From here questions can be asked like this. 4 options will be given and you have to identify the tertiary alcohol, or you have to identify the primary, secondary alcohols. Like that some question can be asked from here. Okay, next, allylic alcohol, what is the structure of allylic alcohol, and next we have benzylic alcohol. Okay, so this structures and the definitions, not definitions, the example you should be knowing, so that you can identify which is an allylic and which is a benzylic alcohol. Okay, next we have vinylic alcohols as well. So whenever OH is attached to an sp2 carbon directly, we call it vinylic alcohols. Okay, next, this is very important here. What are the classification of ethers? Okay, simple ethers and asymmetrical ethers, and we have one more, unsymmetrical ethers. Okay, so what is symmetrical ether and what is unsymmetrical ether? This can be easily a 2-marker question, like define symmetrical ethers with an example, or define asymmetrical ethers with an example. Okay, so you should be knowing this definition. Okay, next, see how this question is. Classify the following as primary, secondary and tertiary alcohols. Okay, so this step, like the question can be classified the following as allylic, vinylic or benzylic alcohols, right? Okay, moving forward, nomenclature. So you should be preparing the nomenclature, so you should know the suffix OL is used in the case of nomenclature. Next, the general rules of nomenclature is used, but yes, here what all things you should be knowing. Some common names are very important, so I'll be highlighting that. You should be now just taking those things. So first one is your N-butyl alcohol, the structure, secondary butyl alcohol, isobutyl alcohol and tert butyl alcohol. Okay, so please make sure that you understand their structures properly, especially the secondary and isobutyl. These are little confusing, so prepare these 2 structures properly, because when conversion questions will be given, right, it may be that they do not give you the IUPAC name, they give you the common name, so you should be knowing the common name properly. Okay, next we have this one also very important, ethylene glycol and glycerol. Okay, their structures and their nomenclature. Okay, now moving forward, we have here this is not very important. Yes, something very important, phenol. Okay, phenol common name is also phenol and IUPAC name is also phenol. Okay, there is one more name of phenol that we will learn in the coming sections. Okay, so next, the common name of these are very, very important: orthocresol, metacresol and paracresol. Okay, and then you have catechol, resorcinol and hydroquinone. Okay, these 6 structures are very, very important, and especially this, okay, catechol, resorcinol and hydroquinone. This can be like MCQ question, 4 structures will be given, which of the following is resorcinol, or simply draw the structure of resorcinol. Okay, so if you do not know their common names, then it is very difficult to do it. So you cannot afford to lose marks here. It is very simple. So make sure that you practice these names properly. Okay, so that is there in the nomenclature part. Next, ether. Yes, ether nomenclature is very, very important again. So here you can just practice the nomenclature of these ethers. So whatever examples are given in this NCERT book, okay, these topics, just practice their nomenclature of ethers. Alcohols generally we know because we use this most probably, like most preferably, but ethers nomenclature are somewhat we feel difficult, because which one should be taken alkyl and which one should be taken alkoxy and alkane, so that you should be little careful. Okay, next, coming to with their common names also. Okay, now we will go towards the physical properties, I guess. Here IUPAC name you can practice, in text questions IUPAC name also you should practice. Okay, next, coming to structures of the functional groups. Okay, so here some important questions are there, very, very important. The first question here, please underline or highlight it. The bond angle in alcohols is slightly less than the tetrahedral angle. Okay, bond angle in alcohols is less than the tetrahedral angle. So answer here is, it is due to the repulsion between the unshared electron pairs of hydrogen of oxygen. Okay, this is the first question. You can just this can be explained why. Okay, next, the question here is, the carbon oxygen bond length in phenol is slightly less than that in methanol. Okay, so this is because in phenols it is sp2 carbon is used, whereas in alcohols sp3 carbon is used. Okay, so this can be another question. Now you can see here, this is due to the partial double bond character on account of the conjugation of unshared electron pair. So this question answer is this one, this question answer is this one. Okay, next, the question is, the bond angle is slightly greater than the tetrahedral angle due to the repulsive interaction between the 2 bulky R groups. So this is about which functional group? This is about ether, the bond angle of ethers. Okay, is slightly greater than that the tetrahedral angle. Explain why. Okay, so again this is due to the repulsive interaction between the 2 bulky R groups. Okay, so you can see from the structural part we got 3 questions. Okay, note down all the 3 questions and their answers. Okay, now moving towards the preparation. So acid catalyzed dehydration, this is acid catalyzed hydration. This is important because here mechanism is there. Okay, so make sure that you prepare this reaction properly. Okay, this mechanism is very important, prepare it thoroughly. Okay, next we have hydroboration oxidation reaction, this mechanism also you should prepare. Okay, next we have reductions of aldehydes and ketones. So first one is your by addition of hydrogen in presence of catalyst. So which are the catalysts that can be used? Platinum, palladium or nickel. Okay, then we can also use LiLH4 and NaBH4. Okay, this is important. Aldehydes will give you primary alcohol, whereas ketones will give you secondary alcohols. Okay, next, if we move towards the second method by reduction of carboxylic acids or esters. So we know that if we treat lithium aluminium hydride, then carboxylic acids will be converted to alcohols. But here a question may arise, what is the limitation of this method? Okay, so you should know that here this is important, that LiLH4 is an expensive reagent. Okay, so that is why it is not a very preferred method. So instead, then what is the commercial method? This is very important question. Commercially, how acids are reduced to alcohols? What is the commercial method? So in Brahmastra also I have did this question. So that is by converting the acids to esters and then reducing the esters to alcohols by using hydrogen. Okay, next we will move forward. Coming to third method from Grignard reagent, here no such questions can be asked, just you should know the mechanism. Okay, these are all there. Okay, yes, so here what happens, if you have Grignard reagent, okay, then you will get primary alcohol only with methanol, secondary alcohol with any other aldehyde, and tertiary alcohol with ketones. Okay, so this is also important, you can highlight this point. Next, coming to the IUPAC name and everything, you should do this part. Okay, now here this is important, phenol also known as carbolic acid. I'm damn sure that many of you might not be knowing this part, that phenols are also called as carboxylic acid. This can be a very tricky MCQ question, but those students who have watched this series will be able to do it. Okay, so please highlight this. Then and first time it was isolated from coal tar. Okay, next, moving forward, what all things are there? Okay, from preparation, so first one is from haloarenes, how to prepare, you should know the reactions. Next, from benzene sulfonic acid. Next, you have from diazonium salts. Okay, next you have cumene. Okay, so cumene method is very important. Okay, why? Because this is the commercial method. Okay, so this is important, you should be knowing this one, every year question is asked from here. Okay, so cumene method, prepare it thoroughly. And what is the byproduct of cumene reaction? So acetone is the byproduct. Okay, fine. Next, moving forward, so you should be knowing this one properly. Okay, okay, next if we move, so this NCERT in-text questions, please solve it. Okay, now moving to physical properties. Okay, so physical properties involve boiling point and solubility. So talking about boiling point, the boiling point of alcohols and phenols increase with the increase in number of carbon atoms. So that is because increase in van der Waals forces. Okay, next, in alcohols the boiling point decrease with the increase of branching. This is just like haloalkanes and haloarenes. Okay, next, the OH group in the alcohols phenols is involved in intermolecular hydrogen bonding. Okay, okay, next, here a question may be this one, like why the boiling points of alcohols and phenols are higher in comparison to other classes of compounds like hydrocarbon, ether, haloalkanes and haloarenes. So this is there definitely because of hydrogen bonding. You can see here the high boiling point of alcohols are mainly due to the presence of intermolecular hydrogen bonding. Next, solubility. Solubility is also due to your hydrogen bond with water as shown. So you should be knowing this diagram, how to show the hydrogen bonding. Okay, next we will go to chemical reactions of alcohol. So first is alcohols can behave as both electrophile and nucleophile. So here a very potential question is that explain how alcohols can behave both as electrophiles and nucleophiles. Okay, so you can write alcohols as nucleophile, this reaction. Okay, when the bond between when the bond between O and H is broken, it is behaving as a nucleophile, and when the bond between C and O is broken, it is behaving as an electrophile. Okay, so this two reactions you should be knowing. Okay, this can be a very good question. Next, moving forward, reactions involving the cleavage of OH bond or the nucleophilic nature of alcohols. First one is reactions with metals. Next, we have here also just nothing much is there. Yes, here there is something important. Alcohols and phenols are Bronsted acid. Why? Because they can donate a proton to a stronger base. Okay, they can donate a proton, so that is why they can behave as a Bronsted base. Now, regarding acidity of alcohols, electron releasing group will yes, so here the question is why the electron releasing group decreases the acidic strength. Okay, why the electron releasing group decreases the acidic strength? The answer will be an electron releasing group increases the electron density on the oxygen, tending to decrease the polarity of OH bond. Okay, electron releasing group increases the density on oxygen and hence decreases the polarity of OH bond. That is why an electron releasing group decreases the acidity. Okay, this can be a very potential question. Okay. Next you can see, so that is why primary is more acidic, then secondary, then tertiary. Next, if we see, alcohols are weaker acids than water. Okay, this can be also question, like explain with an example or explain with a reaction. Then you can see that when water is present, okay, so when water is present, it will accept one H plus from water. Okay, when alcohol is present, it accepts H plus from water, so it behaves as a base. Okay, water is a better acid than alcohol. So if it is asked to explain with an reaction, you can write this particular reaction. Okay. Next we have another alkoxides are stronger bases. Okay. Alkoxide ion is a better proton acceptor than hydroxide ion, which suggests that alkoxides are stronger bases. Okay. Next we have alcohols act as bronze state bases as well. It is due to the presence of unshared electron pair on oxygen, which makes them proton acceptors. Okay. So we have just discussed before now this, that alcohols are bronze state acids because they can accept H plus. Okay, and alcohols also can be as bronze state bases because they have the unshared pair of electrons on oxygen, which can accept a proton. Okay, so the two questions here can be like, why alcohols can behave as a bronze state acid, why alcohols can behave as bronze state base. Okay, you can see here we have written this part. One second. Yes, alcohols and phenols are bronze state acid. Why? The reason is here. Reaction, you can write it this way. Then why alcohols are bronze state bases. Okay, this is the answer. Next, coming to acidity of phenols. So here this one is there. Okay, 1 minute. Okay, the reaction of phenol with aqueous sodium hydroxide indicates that phenols are stronger acid than alcohols in water. Okay, so phenols are stronger acid than alcohols in water. What is the reason for that? You have the reason here. Okay, so the question here I have added, why phenols are more acidic than alcohols. Okay, I think it is visible. Why phenols are more acidic than alcohols. So you have to write this paragraph as an answer. You can formulate it in your own words, but the content should be same. Okay. Next, 1 second. Yes, here the question is, why phenol is less stable than phenoxide ion. Okay, why phenol is less stable than phenoxide ion. The answer here is, see, although there is also charge delocalization in phenol, its resonance structures have charge separation, due to which the phenol molecule is less stable than phenoxide ion. Okay, so you can see here. This is the resonating structure of phenoxide ion. Okay, there is no charge separation, but here if you see the resonating structures of phenol, I think it is there somewhere. Okay, there is plus and minus, right? Plus and minus is there, so charge separation is there. So that is why that is less stable. Okay, this can be a potential question. Next, coming to the presence of electron withdrawing group at ortho and para position increases the acidity. Okay, the presence of electron withdrawing group at ortho and para position increases the acidity. What is the reason for that? So this can be the answer here. Okay, because it is due to the effect of the delocalization of negative charge in the phenoxide ion when substituent is at ortho and para position. Okay, next, moving to here, we have seen the acidic order. Esterification reaction is very common here. Okay, now something is about esterification reaction. So see, the reaction with carboxylic acid and acidic anhydrides is carried out in presence of small amount of concentrated H plus. You can see here. Okay, now this reaction is reversible. Both the reactions are reversible. You should know the nature of the reaction. Next, water is removed as soon as it is formed. Here water is removed so that because it is a reversible reaction, so it should be removed. Okay, similarly in this reaction with acid chloride, pyridine is used to neutralize the excess of acid. So question can be like, why pyridine is used with the reaction of acid chlorides with alcohols? That can be the answer. Okay, next, what is acetylation and aspirin structure? The reaction of aspirin is very, very important, so you should be knowing this part. Next, reaction involves the cleavage of CO bond. So here you have the general Lucas reagent and the Lucas test is there, that I think everybody should be knowing. Okay, then we have dehydration reaction. What all reagents can be used as dehydration reaction? First, generally we know H2SO4 and H3PO4, but some others like anhydrous, zinc chloride or alumina can also be used. So why I am telling you is, suppose a fill in the blanks question is there and you know that only H2SO4 is a dehydrating agent, but some reagent like this one is given. Okay, so you should not get confused there. So these all reagents will do the same reaction. Okay, next we have here one second. Okay, these are all H3PO4. Okay, now the order of dehydration. So first tertiary, then secondary, then primary. Okay, then this is also very important, this mechanism. So this is the second mechanism of the chapter. First mechanism was the hydration of alcohols, and this is the dehydration of alcohols. Okay, this mechanism is super important, so you should prepare it properly. Next, oxidation. So what is oxidation of reaction of alcohols involved? So oxidation reaction involves one bond breaking. These two bond will break with the converting it to C double bond O. So this is also known as your dehydrogenation reaction. Okay, so question can be like, why oxidation of alcohols is also called as dehydrogenation reaction? So yes, you can answer it very easily from here. Next, okay, so next is your strong oxidizing agents such as acidified potassium permanganate are used for getting carboxylic acid from alcohols. Now CrO3 in anhydrous medium is used as oxidizing agent for the isolation of aldehydes. Okay, so you can just see the reagents here. CrO3 will convert alcohols to aldehydes. Similarly, you have PCC for this one. Okay, then you can use CrO3 to get secondary alcohols, will give you ketones group. Okay, next we have copper at 573 Kelvin and its reactions. This is all of you will be knowing about the reaction. Next, coming to reactions of phenols. Okay, in phenols we find electrophilic substitution reaction. Why? So the reason here is the OH group attached to the benzene ring activate it towards the electrophilic substitution. So due to the presence of OH group, the ring is activated, means it is electron rich, so it will automatically react with the electron deficient, so electrophile, and that is why it is electrophilic substitution reaction. Okay, next we have reactions that of nitration with dilute nitric acid will get separate products. Okay, and here about ortho and para isomers, there are something, they can be separated by steam distillation. Okay, next, orthonitrophenol is steam volatile due to intramolecular hydrogen bonding, while paranitrophenol is less volatile due to intermolecular hydrogen bonding. So if you do steam distillation, this one will easily evaporate, orthonitrophenol. Paranitrophenol will evaporate later. Okay, so it is having low boiling point, it is having high boiling point. Okay, so you can see here hydrogen bonding in orthonitrophenol and hydrogen bonding in paranitrophenol. Okay, next, if you use concentrated nitric acid, what will be the reaction? This is also there. And here something very interesting I found is how picric acid is prepared nowadays. So earlier how picric acid was prepared, if you just treat concentrated nitric acid, you will get it. But here something is given. Now picric acid is prepared by treating the phenols first with concentrated sulfuric acid, which convert it to phenol 2,4-disulfonic acid, and then concentrated nitric acid to get 2,4,6-trinitrophenol. Okay, this has less probability, but yes, something different which you might not be knowing if you haven't studied it is given, so you should put some attention here. Next, coming to halogenation reaction. So in halogenation reaction, if you use like Br2 in CHCl3 or CS2, you will get different products, but if you just use bromine water, you will get tribromo product. Okay, now here one more thing is there, that generally when you just recollect the reactions of haloalkanes with bromine, okay, or just if you want to do bromination in benzene, you use Br2 and FeBr3, right? So this Lewis acid was used to generate electrophile, but in case of alcohols, in case of phenols, we do not need any Lewis acid. So why? The reason here is, you can see the usual halogenation of benzene takes place in the presence of Lewis acid such as FeBr3. In case of phenol, the polarization of bromine molecule takes place even in the absence of Lewis acid. What is the reason? Now it is due to the highly activating effect of OH group in the benzene ring. Okay. Next we have here this Coles reaction. You should be knowing the statement and the reaction. Next we have Riemer-Tiemann reaction. Next we have zinc dust reaction and oxidation reaction. So all the reactions and their products definition should be known to you. Okay. Next we will move towards some commercially prepared alcohols. The first one is your methanol. So first thing you should be knowing is it is called as wood spirit, and what is the reason for that? Because it was produced by the destructive distillation of wood. Okay, next, that was the earlier method. Now how methanol is prepared in today's day? So it is prepared by the catalytic hydrogenation of carbon monoxide. Okay, so this reaction can be a question. Next, what are the harmful effects of methanol? That is there, just note down some 2 to 3 harmful effects of methanol. Next, coming to ethanol, how ethanol is produced. Okay, so this is ethanol from sugar. First it is converted to glucose and fructose. From glucose, it is by enzyme zymase, it is converted to ethanol. Next, it is there what happens in the wine making of grapes. Okay, I have given this heading, wine making of grapes. So you can see here, and this paragraph is about wine making from grapes, the process you should be knowing. Next, here one condition is there, that fermentation takes place in anaerobic condition. Okay, I think I had added a question here. Yeah, you can see why fermentation takes place in anaerobic condition. So the answer for here is, if air gets into fermentation mixture, the oxygen of the air oxidizes ethanol to ethanoic acid, which in turn destroys the taste of the. So this question answer is here. Okay, why fermentation takes place in anaerobic condition, answer is here. Okay, next, moving forward, what is denaturation of alcohol and how it is done? By adding some copper sulfate and pyridine. Okay, so this is also important question here. Next, moving to, oh sorry, 1 second, 1 second students. Okay, fine. Now moving forward towards preparation of ether. So here the mechanism is there, that should be very, very important. This mechanism very important, so please prepare it thoroughly. Okay, yeah, 1 second. Okay, so this is important. Okay, mechanism. So 3 mechanisms are there in this particular chapter. First is hydration of alcohols, dehydration of alcohols, preparation of ethers. Okay, 3 mechanisms are very, very important, should be practiced thoroughly. Okay, next, moving forward, we have Williamson ether synthesis, the reaction and everything about the Williamson ether synthesis. One more important, the reaction involves SN2 mechanism here, if it is a primary alkyl halide. Okay, now here something important, that the alkyl halide should be primary, this we have studied also, right? And in case of secondary and tertiary alkyl halides, elimination competes over the substitution. So question may be rise, why primary alkyl halide should be taken? So that is because if you take secondary or tertiary, then elimination will dominate, and you will get, if tertiary alkyl halide is used, and alkene is the only reaction product and no ether is formed. Okay, so for ether formation we need substitution reaction, and that will happen if we use only primary alkyl halides. Okay, so you can see here this one, right? This one is a alkoxide ion and this is a primary alkyl halide. So this one attacks on this one and this goes. So you can see this Br is replaced by this group. Okay, that is substitution reaction. But if in case this one you take some tertiary, so you can see here one example. Yeah, you can see here, this is a tertiary alkyl halide and this is an alkoxide ion. Okay, now if this is present, what will happen? It will favor elimination reaction and you will get an alkene as a major product and not ether. Okay, so that is why it is always primary alkyl halide. Okay, what is the reason for that? It is because alkoxide ions, these alkoxide ions are not only nucleophiles but they are also strong bases. So if they behave as strong bases, then we will get elimination product. Okay. Next, moving to we have physical properties. So you can see that, sorry, 1 second. Okay, so the large difference in the boiling point, you can see ethoxyethane and here butanol have large difference. That is because there is no hydrogen bonding in ethers. Okay, next. 1 second. Okay, so there is no hydrogen bonding between the ethers. Okay, but ethers are highly soluble in water because they can form hydrogen bond with water. So you can see the hydrogen bonding of ether with water, but there is no hydrogen bonding between two ether molecules. Okay, so that is why their boiling point is very less. Next, coming to chemical reactions of ether. So this reaction is very, very important, reaction with HX. So what products will form in what case, that you should be knowing. Okay, so that is there, and here some order is also there, this is important. So 1 second, let me underline it. Yes, the order is HI, HBr and HCl. Okay, so HI if it is there, because of, I can say, what is there, that is like difference in sizes, the bond is very weak, so H and I bond can break easily, so that is why it will react faster. Okay, next I think that's all in this chapter. Yeah, these all products you should be knowing. Okay, let these examples: electrophilic substitution, very simple, halogenation, nitration, Friedel-Crafts alkylation, okay, nitration, these are normal reagents are used. Yeah, that's all in this chapter, students. So yes, I have given you every question that is possible which you might not prepare. Okay, so make sure that you read these particular points, make a note and write down all the questions that I have told you. Okay, so frame your own questions and make a note and give a heading like extra questions from alcohols or some unexpected questions from alcohol, something you do write that and prepare this chapter. Okay, and if you do all these questions and the Brahmastra series that we have done, then all your subjective questions from alcohols are done. Okay, now you might be worried for MCQ, so please do not worry, we will solve all the MCQs of all the chapters very soon. Okay, so that's all, students, in this class, and I hope this lecture was helpful. And if you find this helpful, please let us know or give your feedback about the class. If anything else you required or anything else that could be done for you people, please let us know. Okay, that's all, students. Thank you so much and see you soon in the next class, and do not forget to subscribe the channel.